Hi, everyone. My name is Sarah Mansfield. I am currently a second year in the MSS program, but will be graduating as part of the class of 2022. I was asked to record and share my portfolio presentation from this year to hopefully serve as an example for future students and give a bit of general guidance on what your portfolio presentation might look like if you do choose to do one as part of your completion exercise. So I was given about 15 minutes to do this presentation when I did it, but that might be give or take a few minutes for today because I'm gonna be a little bit less formal. But yeah, I'll go ahead and get started. So the topic that I chose for my portfolio presentation, I chose to talk about my project for my summer internship with Liberty Mutual, which centered around classifying email text data using natural language processing and machine learning techniques. So to give a little bit of background just on the company itself and the problem that we have here. So Liberty Mutual is, for those of you who don't know, it's an insurance company that offers a wide range of insurance products and services. And within Liberty Mutual itself, there's a team called the Presidential Services Team. And what it does is it handles email complaints and inquiries from both customers as well as insurance regulators that work with Liberty Mutual. So based on its contents, an incoming email can take either one of two routes. The first is that it's marked as spam and deleted. The second is that it is forwarded to a certain functional area within the company. So up until the point that PST reached out to my team and wanted to collaborate with the data scientists within the company, it was dealing with all these incoming email complaints manually. And so what that means is they were just having members of the team read each email and then from that determine like which email it needed to be forwarded to, which functional area it needed to go into within the company. So they came to us seeking increased efficiency around this. And so our objective here was simply just to create a model that automates the email triaging process for them. And, as a result, free up a lot more time for them to do other things. So going into the data that was used in the project, the data consists of 6,036 unique emails. And this was kind of pared down from a lot of email repeats that came from, forwarding the same email around the company, trying to get it to the right functional area. There are four main functional areas that an email can be sent to, which are claims, distribution, spam, not spam, accounting, billing, and underwriting. And 19% of all of these emails did consist of spam mail. So if you look at this plot in the center here, you'll see that there's a pretty large imbalance between classes. Most of the emails, like half of them are claims. Then the next two, most populous ones are distribution as well as spam. And then on the right here, you just don't see a lot of emails that are getting classified into accounting, billing, and underwriting. And so this is a problem that will come up later in terms of imbalanced classes. And I will talk about kind of how I dealt with that when it came to the modeling process. So the relevant data fields that I used were subject, was just the subject line of the email, verbatim, which is the entire email body, as well as functional area, which determines, which functional area an email needs to be classified under. And then something to note here is that I did have to manually assign labels to spam mail. And that's because we did want to set up a process where we were able to classify spam mail as well. So moving on to the methods that were used, the three main ones I'll go over are the text cleaning and pre-processing step, TF-IDF factorization, as well as the modeling architecture of the model that was used. So first of all, text cleaning and pre-processing, this is a pretty necessary step when it comes to natural language processing and when you're dealing with text data. And this is just, cleaning up the data so that you can prepare it for the modeling process later on. So first, I did apply text cleaning to both the verbatim and the subject. And the four main steps that were used were first to remove punctuation, special and single characters, just because these don't give us any information, like any relevant or valuable information when it comes to a piece of text data. Second is to convert everything to lowercase, just because we don't want anything to be case sensitive. Third is to remove stop words, and these are just words like is, a, are, the, just very common words within the English language that, again, don't tell us a ton of information. And so they're kind of unnecessary in the overall process. Fourth step here is to apply stemming, which is a process where you essentially just chop off the ends of words. So like flying would become, fly, just because these are essentially like the same words that tell us the same kind of information, and we don't want to make a distinction between the two. And then lastly, in this process, which is to add together those two clean bodies of text to form the full email text that will be used in the modeling process later on. So second step here is TF-IDF vectorization. TF-IDF is a statistical measure that evaluates how relevant a word is to a document in a collection of documents. And TF-IDF vectorization is another pretty common step in preparing text data for the modeling process, because text data is unstructured data, and we do need to convert it to something structured, something with numbers, so that we can actually use it to model and predict. So the TF and TF-IDF stands for term frequency, which is the number of times a term appears in a document, and IDF is inverse document frequency, which is a measure of whether a term is rare or common in a collection of documents. So IDF, the IDF function, there's a couple of different functions that you can use for it. I was coding everything in Python, and so the sklearn implementation that I used uses this formula here, where I believe n is the total number of documents, and DFT is the document frequency of a term T. So if you look at the example TF matrix here below, you'll see that, on the left here, you have these different email texts, for example, like going off of, this project itself. And then each row is each email's clean text. The columns represent all possible terms that you want to use. And then you'll see that each value within, each little cell tells you how frequently each term appears for each individual, clean text. And then once you would apply IDF to this matrix, it would weight terms to account for frequent occurrences. So, the higher IDF is, I believe, the more rare a document is, and then vice versa. So IDF would just tell us, information about how rare each term is within the overall document corpus. And so then we can kind of use that as information to make predictions on where an email might belong based on that score. So lastly, the general modeling architecture of, the model that was built. The first step here, which doesn't technically have a ton to do with the modeling process, was to filter out and flag high priority emails. And this was more of a business decision, because Liberty Mutual does get emails from insurance regulators that, under no circumstances can they be marked as spam or deleted. They also kind of require an agent to log in and to view the full text message. So I just didn't have access to that over the course of my internship. So second process, so there's a main two-step process for the model itself. The first is the binary classification of spam mail. So first step in this was, again, to create that binary spam label that was briefly mentioned in the data section. Then to perform that TF-IDF vectorization to all of our data, and finally to feed that into a naive Bayes classifier. So if this binary model predicts true, the email is marked as spam and it's deleted. Otherwise, it's marked as non-spam and it's fed into the next step, which is a multi-class model. The multi-class model does a classification of those four main functional areas that was mentioned earlier. Again, takes that step of TF-IDF vectorization to properly transform our data, The second step here is to oversample our minority classes. As was mentioned before, we did have that pretty marked imbalance between our classes. And so we want some sort of method that can hopefully help mitigate that. The oversampling method I used here was SMOTE, also known as synthetic minority oversampling technique. And, just very generally, it uses a k-nearest neighbors approach to kind of oversample and create synthetic samples from the minority class to hopefully help out with this class imbalance issue. And then lastly, once the oversampling is done, the data is fed into a machine learning classifier, which will predict one of those 4 functional areas and forward the email accordingly. And then a quick note here again, the data was split using an 80-20 train test split, and model hyperparameters were selected using 5-fold cross-validation during the training process. So moving on to results for the models for the binary classification model, it performed exceedingly well. As you can see, it had a 99% accuracy, recall, and precision. And breaking that down even further, that means out of 830 emails used in the test set, only 6 ended up being misclassified by the model. You'll see from the table on the right here, some of the predictive words that were identified as being particularly indicative of, either spam mail or non-spam mail. For example, under spam, you'll see a lot of words like unsubscribe or commercial, whereas for non-spam mail, you'll see words like claim, policy, number. And then moving on to the multi-class classification results, I tested out 4 main ML models here, which the first one was a linear support vector classifier, second was XGBoost, and then like GBM and random forest. So if you look at this plot, this kind of, pictures the recall across each of those 4 main functional areas. Overall accuracy-wise, they all perform pretty similarly with those 3 tree-based models, performing at about 80%, 87% overall accuracy, with the linear support vector classifier clocking in at around 84%. But you will notice here that for XGBoost, like GBM and random forest, they did a pretty awful job at identifying, accounting, billing, and underwriting our minority classes despite using oversampling. And that's just because, some of these models tend to just overfit on the majority classes that we have. Whereas for the linear SVC model, the performance was slightly worse for our majority classes, but they did much better when it came to identifying minority classes. So again, this model had, lower overall accuracy, but higher predictive power for those minority classes. And that was why the linear SVC model was chosen as the final multi-class classification model. So again, table on the right, you'll see like for claims and distributions, some of the terms that were, most predictive. And so you'll see like for claims, for example, you see words like appraise, claim receive. For distribution, you'll see like request, call, policy, receive. So leading to my conclusion, some general takeaways from the project. We did see that naive Bayes was pretty effective when it came to separating spam mail from non-spam mail. And the linear SVC model here was really effective when it came to identifying those 2 majority classes, but still did struggle like with the rest of the models at identifying those minority classes. So next steps, as kind of discussed with my manager during the conclusion of my internship, was to just continue to collect more data pertaining to this minority classes so that hopefully the model can get better at, training and identifying those. Second, which I didn't get a chance to do, was to try deep learning models such as Word2Vec and BERT, just to see how those might perform compared to some of the more classic traditional ML models. And the third, would be to extend the model to those regulatory emails that did have to be filtered out and couldn't be applied, as mentioned before. So that takes me to the end of my presentation. Hopefully this was helpful and provided a bit of a general idea of what your presentation might look like. And just best of luck to anyone who is currently working on, preparing for their presentation. And thank you, good luck.